Here on how to use named cells in Excel as an easy and reliable way to put equations into a spreadsheet. In this case, we have a table in blue here that we need to fill out based on for different configurations, flywheels with different number of bolts and different number of nuts. These calculations of flywheel mass depend on a bunch of parameters that we have here, and I set it up in a very specific way, which you'll see shortly why. But I have one column has a description, then I have a column of names for each variable. You'll notice there are no spaces in the names, and they really don't use numbers because you have to avoid numbers that could correspond to a cell, such as cell C1. Then the next column over are values, just numerical values, and then units. I always put units next to a value because it's different not to. There's some values that were blank. They have to be converted over from what we got in the spec sheet. So let's just start by doing that. It's pretty easy. If I have a millimeters here, I can just see equal, grab these millimeters and divide by 1,000, and you see the equation is F13 over 1,000. And if I copy this down to these other conversions of millimeters to 1,000, you see it goes to F14 and it goes to F15, so it automatically updates the equation. That's called a relative reference, and spreadsheets work really well in that way. We can use that also here for grams. I just do the grams divided by 1,000, and I bring that down for the grams. For the meters to inches, I have to multiply by 2.54 to get the centimeters, divided by 100 to get the meters. And then for the kilograms, I just do divided by 1,000. Now I also created I put in gravity here just to make my equations look nicer. So you see the automatic references work really well here, or the relative references, but they will create a problem if I want to look at for the mass of the flywheel. For example, here we have a flywheel without bolts, and I would start, one of the things I know I need is a density. So if I just go here and I click on this density equation, that's D22. It's not the complete equation, but just to demonstrate, if I copy it down here, it changes from D22 to D23 to D24. It's it's updated. I don't want to do that. I want to always use density or have it the same value for density. I could use an absolute reference, which is putting a dollar sign in front of that, but I'm going to show you something even better. And what we're going to do here is, it's available in Excel, this approach. I'm going to highlight these two columns, and this is the key equation right here. I'm going to do insert, name, create. And what it gives me, the default option is a left column. So this left column are the labels that are going to become the names. The actual variables are these cells. So now I just click OK. And it's done. And you can see, for example, if I go to this flywheel and I want to start the equation with the inertia, if I do equal and I move over and click on that cell, it's in. And not only is it 1180, it's shown as P. And I can copy it down, and it knows that I want to keep it absolute because why else would I have named it? So now I want to put in the actual equation for the mass of the flywheel, and I actually copied it down below here. The mass of the flywheel equals the density of the acrylic times the volume of the flywheel plus the mass of the bolts plus the mass of the nuts. And here, in fact, is density times thickness times pi r squared of the flywheel plus the number of bolts times the mass of the bolt plus the number of nuts times the mass of the nuts. And we see here that the number of bolts are given here, but the number of nuts per bolt could be more than one because we could have add more mass. So let's do this equation. And one thing that you notice right off the bat is I can actually type it using the numbers. So I could equal P times the thickness of the flywheel. We see here that's T flywheel times pi. Now we want to do r, but we actually have the diameter. So I'm just going to open a parentheses, click on that. It gives me the diameter divided by 2 squared. And lo and behold, there my equation is, and it's readable, which makes it so much easier to do. Now the one thing is this has 0, oh, this was a flywheel with no bolts. Oh, my mistake. Let me put that up in here, and you notice the equation stays the same, but now that this one has some bolts, I need to modify that. So I'm just going to add an equation here where I multiply by the number of bolts. And then I'm going to open a parentheses because I'm going to want to include the weight of the bolts in here, plus multiplying the number of nuts times the weight of the nut. So now I have another equation that's readable, and it looks reasonable. And now I can just copy this down. And it automatically goes, we see the equation, the only things that change in the equation on these references, and it actually makes sense. These last 3 have the highest weight, and they're all identical because they all have 8 bolts and 3 nuts. Their moment of inertia will be different because they have different radiuses, but that makes sense that these 3 are the same and those 3 are the same. And what I can do is I can copy this equation here just with the screen copy. And I guess I had an old version here, but I'm going to just put this one in here. Oops. It moved over there. I'm going to put it here, and I can just check this. It looks like it. The equation looks correct to me, and I'm good to go. Another thing that's useful is I could print it out and show the numbers or save it as a PDF, or I can hit Control tilde. If I hit Control tilde, I actually see the equation. So real useful if you want to see what's in the spreadsheet. So this is using name cells. You can also go to Google Sheets, and Google Sheets has absolute and relative references. And to absolute, you can use the dollar character, as it'll show you. It can actually name the cells too, but it isn't as convenient because you can't do this column effect. Now, after I did all this beautiful tutorial, I realized that unbeknownst to me, the weight of the flywheel had been added here, and it was 0.061. And I said, oh my God, I calculated 0.07. That's more than a 10% error. But I thought about it a bit, and I thought, well, you know, our acrylic, usually we buy it as a 1/4 inch, but usually they jip us a little bit. They try to save money, so it's a little bit low. So that's maybe one reason. But then I realized I had all these holes on the acrylic. The acrylic almost looks like Swiss cheese. So if you want a more accurate number for the acrylic, you can subtract out the acrylic for each hole, and it will even be more accurate. So hopefully this tool shows you a technique that you can have the power of a spreadsheet of seeing all these numbers together, but making it easier to write out the equations and easier to check that your equations are correct.